Okay. So it looks like for the next, maybe this class, I don't know about Monday. I think a lot of you are still going to be out. And some of you are allowed to come back next Monday. So we'll play it by ear. I think if there's like at least 3 or 4 people in class, I'm going to have it in the classroom. But like I did this morning, I'll set up my laptop so you could kind of be in the class if you wanted to be. Frank came live this morning in tax because he got my email early enough, and be in class with me and, and everyone. I'll record these sessions also so that you can listen to them later in case, you aren't feeling well or you didn't get out of bed early enough for like tax class, or if something's going on that you can't attend this class. I'm going to upload this recording into YouTube and then give you guys, we'll just link it into Learn. You just click on it and it's good to go. Okay. So are there any questions before we get started? All right. So 1, 2, 3, 4. We got a nice showing. All right. Let's go then to chapter 5. Chapter 5 is very, very different. And let me see if I can share this. There we go. So you should see my chapter 5 PowerPoints. Let me put the slideshow on. And now you should see it. So if you have any questions, just unmute yourself and ask away. I think Alicia might have been one of our last ones to join, but if you do have access to like a scientific calculator that has an apps button, hopefully I can't see if you can see this or not, but I have a blue little apps button on my calculator. That will help us do some of the calculations that we're going to be looking at. If you don't, no big deal. If you grab your intermediate accounting book, okay, in the very, very, very back, there are tables, page P1, P2, P3, and they look like this. Okay, there's 6 of them. 1, 2, 3, 4, 5, and 6. Okay, we will be utilizing these. So I'm going to show you a couple different ways to do the calculations we're going to be working on. One, we could use tables. Another is your calculator using an apps function on your calculator. And there's still another with formulas that are at the top of the page of each of these tables. Okay, so you want to have access to that. What are we going to be talking about? It's really a finance area, and it's called the time value of money. So let's first try to wrap our head around what the heck it is we're looking at here, and then we can look at the nitty-gritty of the calculation starting today. So time value of money is exactly what it says there. It means that money invested today to earn interest will grow to a larger dollar amount in the future. And the assumption is all money is earning interest into the future. For example, you invest $100 today to earn 6% interest a year. At the end of 1 year, you will have $100 plus 100 times 6% or $6, $6 being the interest right in here. You guys can't see my finger. There we go, right in there, or $106. So today's value is the value we invested. We call that time 0. So the day you make that investment is time 0. And the amount in the future, whatever that future may be, in this case, it's 1 year, is the future value of that money. So time 0 we often call present value. Amount in the future, future value. In accounting, we use the calculations you'll be learning in this chapter to value or determine how much to report an asset at, and sometimes a liability. And you'll see that as you go more through intermediate accounting. So if you're sitting there going, well, I thought we just record an asset at its cost. That's true. Sometimes we don't know what it cost today. At time zero, present value, when we have to record it. For instance, here's an example. Let me do a sharing of an Excel. Oh, come on. I'm using my laptop and I hate using it. Hold on. I don't have all my wireless mouse and keyboards. So just bear with me a second. Okay. Let me put Excel up so you can see this. Okay. So let's say, whoops. Here's an example. Company A purchases a piece of equipment on 10/19 of 2020. They will pay $10,000 in 1 year and $10,000 at the end of the second year. Okay, so company A isn't even paying for this piece of equipment today. They don't owe any money until 1 year from now, which it'll be 10,000. And then they'll owe another 10,000 at the end of year 2 to whoever they're buying it from. How much did that equipment cost? Well, we don't go 10 plus 10 is 20,000. No, because within each $10,000 payment, the seller is charging company A interest. We just don't know how much. It's not broken down. So the real cost of this equipment is those two $10,000 payments with the interest taken out of it. This is where we would use these calculations. Now, if you're like, I don't even know what the calculations are, that's what we're going to show you. So sometimes we don't know what that specific piece of equipment cost, but we could figure out the actual cost, what we bought it for, by using the concepts you're going to learn in this chapter. I'm going to come back over to my PowerPoint. That's not the one I want. All right. So in accounting so far, we've calculated interest under what's called the simple interest. What does this mean? We calculate interest on the amount of money that we borrowed or we loaned. So the amount of money that we'll receive or we pay in excess of the amount of money borrowed or loaned is called interest. Simple interest, we assumed that there was an initial investment. So either we borrowed the money or we loaned the money, and we received the entire amount of what we loaned or borrowed, plus the interest on it at a future date. So we calculated interest by taking the original amount we borrowed or loaned times the annual interest rate. Remember, interest rates are always stated in annual terms, times the period of time we need to calculate interest for. That gave us our interest. Well, that's not how the real world normally calculates interest. It's a little bit more complex than that. Interest is usually calculated on not only the initial investment, but also any interest that's accumulated and added to that initial investment from previous periods. That's called compound interest. So if your loan says, we are going to, let's show you a quick example, show you the difference. We'll do a simple interest and then we'll do a compound interest. Well, let's do it this way. Company A invests $10,000 in a savings account that will earn 6% simple interest over 3 years. Okay, so company A invests $10,000 in a savings account that will earn 6% and just a simple interest calculation over 3 years. When we calculate simple interest, we only use the initial investment made times the annual interest rate times the period of time that we want to accumulate or calculate interest for. So how much interest occurs over those 3 years? Well, we take I don't know if it's going to work. No. $10,000 times 6% interest. Let's put a little time sign there. I didn't touch that. That just automatically goes on me there. Times, I don't know if I worked too fast for it or what. 3 years. So if we take 10,000 times 6%, 0.06, that equals $600 of interest a year times 3. The amount of interest will be $1,800. So at the end of 3 years, there will be $11,800 in total amount in our savings account. Any questions on that? Compound interest is a little different. Let's take the same scenario. Company A invests $10,000 in a savings account that will earn 6% compound interest annually for 3 years. So just by changing how the interest is calculated, we'll change our answer. So now we're saying, oh, interest compounds. Well, let's calculate the interest. I don't know if anybody else has problems with their laptop keyboard, but mine does funky things. That's probably the way I'm just hitting the keys. Here's year one's calculation. So we're going to take our let's call this investment plus interest. Well, as of time 0 today, the amount of investment plus interest so far will be the $10,000. Now let's calculate. Let me see if I can get this bigger. I need my other mouse. I should have done this from my other computer. Give me 1 second to make this whole column wider. So this will be the interest calculation. So in the first year, we will have 10,000 in interest or principal, still calculate interest the same way, times 0.06 for 6%. And since we're just calculating it for year one, 1 year, that still gives us $600 in interest. What we do, let me see if I, there we go. Okay, is after we add this interest, sorry, we get, I'm just going to type, investment plus interest, $10,600. So at the end of year one, we've accumulated $10,000 plus $600 of interest. Now, simple interest, we just went 600 times 3 because it's $600 a year. Compound interest, if you go back to the PowerPoint, says, oh, all computations of interest are computed on the initial investment plus all the previous interest in the account. So what does that mean? Well, year two, we just don't calculate interest on $10,000. Nope, we calculate interest on the $10,600 that was in the account at the end of last year. So now we're not only calculating interest on the initial investment, but also interest on interest. And that's how the real world works. So we'll take the 10,600 times 6% times 1 year. So when you compound interest, check that out. Now your total interest for year two is $636. 600 on the initial investment, $36 on the 600 of interest that was from last year. So if we add the 10,600 we started with plus this year's interest, now our balance is up to 11,236. At the beginning of year three, we start with the investment plus interest in the account, 11,236, same as last year's ending. And add to that the interest for this year, 11,236 times 6% times 1 year. So I'm just going to round that to $674. So add the new interest from the current year to the beginning balance and look at the amount in the account. Under simple interest, you would have ended up with $11,800. Under compound interest, $11,910, because you're not only earning interest on the investment, but any interest that stays in the account. And that's the assumption here. You don't take anything out of the account. That's how compound interest works. And that's the real world. Are there any questions on that? All right. Sorry for my laptop and the ridiculousness of it. There we go. So I'm going to come back over then. We're going to do a lot of practicing here with stuff so you can see it again. So that's, they take us through another example, kind of like what I just showed you, but one more time. So what is the simple interest earned each year on a $1,000 investment paying 10% interest? $1,000 investment times 10% times 1 year. Each year, it would be $100 because each year under the simple interest, we just calculate interest on the initial investment. But what happens when it's compounded? Well, now take a look. Cindy Johnson invested $1,000 in a savings account paying 10% interest compounded annually. How much interest will she earn? I didn't do this on purpose. In each of the next 3 years. And what will be her investment balance after 3 years? Very similar to what I just showed you in Excel. Take a look. At the end of year 1, when her initial investment was $1,000, multiply that 1,000 by 10%, her interest will be $100. But now future interest computations will be based on the new balance each year after adding the interest. So now her balance is $1,100. So going into year 2, $1,100 times 10% or $110 of interest is in year 2. Add that 110 interest to the $1,100 balance. Now at the end of year 2, her balance is $1,210. Going into year 3 then, she'll use that new balance of $1,210 times 10%. Interest in the 3rd year is $121. Add that $121 of interest to the current balance of $1,210. At the end of year 3, $1,331. So just another demonstration of how this compound interest actually works. Not only do you earn interest on your initial investment, but any interest that's been earned through the end of the year. All right. Now, we're going to come across a couple different kind of terms when it comes to interest rates. One is called the effective rate, or we call it the market rate. And that's the actual rate of interest at which your money grows each year. Okay, I'm sorry. No, what, yeah, we'll just leave it at that. So it gets kind of funky sometimes when we start doing calculations here. Just because you have an annual rate of interest of 12% doesn't mean your total earnings will be 12%. Because if the interest compounds more than once a year, so if you have a certificate of deposit that compounds interest semi-annually, what happens is the bank will say, okay, compute interest for 6 months, add that interest to the balance of the CD, and then the second 6 months, calculate interest on that balance as of the beginning of that second 6-month period. So it's not waiting a whole year to calculate interest. It calculates interest twice during the year. Quarterly, it compounds it 4 times or calculates interest 4 times during the year. Monthly, it'll calculate it 12 times. Now, if you notice what they're doing there in our table, interest rates are always stated at an annual percentage, 12%. If interest compounds more than once a year, we don't use the 12%. We have to find the interest rate for that period of time to properly compound. So if it says a 12% annual rate and it compounds semi-annually, we don't compound 12% for the first 6 months. No, we divide the interest rate by the number of times we compound during the year, in this case, twice. And the interest rate that will be used, 6%. And I'll show you that. If it's quarterly, if our annual interest rate is 12%, compound quarterly, that means the interest will be computed 4 times during the year. So divide the interest rate by 4 to get the proper rate to use to compound. And then you could see with the monthly, take the annual rate divided by the number of months, and that's the rate you use to compound for that period. So let me show you this. I'm going to go back into my Excel. Wish me luck. Come on. All right. Okay, so let's say we'll do a savings account example again. Company A invests $10,000 into a savings account for 1 year. What will be the balance at the end of the year if the interest is compounded annually, semi-annually, and we'll do quarterly, and monthly, and monthly. So we're going to do 3 separate calculations here. If the interest rate is 18%. That's a wish. Okay, so invest 10 grand, calculate interest at different compounding periods. Now, all compounding means is the balance you determine interest on is, or the amount you determine interest on each period is the beginning balance at the beginning of that period. So it would be the investment plus all interest earned to that point that is still in the account. Well, the assumption is no money's taken out. So for annual compounding, we would just, I don't know why it keeps giving me a T. We would take, just like we did before, $10,000 times 18% times, should be 0.18, that should be 18% times 1 year. So $1,800. So the balance that would be in that account would be the 10,000 originally invested plus that 1 year's worth of interest, 11,800. But let's see what happens for the second scenario. Now we're looking at, oh, come on, semi-annual compounding. So we're going to compound for 6 months. So that means we're going to determine the interest for 6 months using the 6-month interest rate, add it to the balance, and then compute the interest for the second 6 months. What's important here is that we figure out the proper interest rate to use. So we take 18%. Hang in there with me. 18% divided by 2. So our semi-annual interest rate that we'll use is 9%. 18% divided by 2 because we're compounding twice a year. So for our first 6 months, starting with a $10,000 balance, so our interest will be $10,000 times 9%, the balance times our 6-month interest rate, $900. So the balance after the end, at the end of 6 months will be $10,900. But we've only computed interest for the first 6 months. Now we'll compute it for the second 6 months. But we don't use the $10,000, we use the new balance, the $10,900. $10,900 times that 6-month interest rate of 9%, 981. Add that 6 months interest to the balance, $11,881. So take a look. When you compound more often during the year, you earn more interest. Once a year, $1,800. Twice a year, $1,881 is the total interest. Are there any questions on that? I don't know if I could do all 12 months. I'll probably kill my computer. I probably could if I set up a few quick calculations. Let's take a look at monthly compounding. Just like before, we need to find a monthly interest rate. So take 18% divided by 12 months. So our monthly interest rate that we'll use is 1.5%. So I'm just going to quickly put in 12 months here because we'll have 12 separate calculations. I'm going to do them quick in Excel just to show you them. So we'll start with our balance, then interest, so our first balance will be the $10,000. The interest for the first month will be the $10,000 times 1.5%. I just put it in as a decimal. So the total amount that will be in that account after the interest is added at the end of month 1, $10,150. Going into the second month, that's the new balance we will use to compute interest. So we'll take the 10,150 times 0.015, interest for month 2, 152.25. Now get a new balance. So it'll be the 10,150 plus the 152.25. There we go. So if we continue to do that calculation, I don't know if it's going to work out for me or not. Let me see. I'm not very good at this. I have my regular mouse, I could copy and paste in 2 seconds, but okay. And then is recalculating as we go. I'm just copying and pasting my. I did something wrong. I see what I did. It's using the wrong thing. No, it's not B40, B41, B42, B43, B44, B45, 46, 47. Should be a little bit higher. Maybe I shouldn't have used Excel, huh? Because it's bothering me. Hold on. Six. Ooh. Something's off in my calculation. I'm not sure where. 613, maybe not. The more times you compound, it should be higher. The interest is appropriately. Oh, there's why. Nobody caught me. I didn't do it for 12. Okay. Now it should be higher. Got to make sure you do 12 periods. All right, and then this. There we go. Sorry about that. Okay, so at the end of 12 periods, you could see, look at that interest now, 1,956. So if you take 10,000, subtract it from 11,956, you have 1,956. So the more times you compound, the higher the interest that will be earned. The important thing to remember is that you divide your annual interest rate by the number of compounding periods when you're doing these calculations. Any questions? Did you turn into that dog yet? Falling asleep during your Zoom class? All right. Let's go down here because I'm going to skip some slides. So again, they're showing in the next one, what happens to $1,000 in a savings account paying 10% interest compounded twice a year, just like we did. So remember, you take the annual rate divided by the number of times you're compounding twice a year. So it's 5% each 6 months. Add the interest and then recompute the next 6 months interest. Oh, let me show you this. Show you what it shows you at the very end here. I didn't do this on the compounding I did, but you can do it. So the total amount of interest earned on this account was 102.50. So that was the interest earned. If you divide the interest earned, total interest earned by the original investment of 1,000, it tells you the effective or how much real interest you made. So it's like your annual rate of interest was 10.25%. That's what we mean by effective annual interest rate. The actual interest earned divided by that original balance of 1,000. So if I hop back over here really quick, the effective interest rate for the first annual compounding will be the annual interest rate, because if we take 1,800 divided by 10,000, we get 18%. But take a look at the second one. The second one, we earned $1,881 of interest divided by 10,000. Now the effective interest rate is 1,881. So it's higher. So the more times you compound more during the year, the actual interest you're earning, the actual rate of interest annually increases higher than that annual rate you were given. So the effective rate. In this last scenario, there was $1,956 of interest divided by 10,000. So the effective annual rate, how much interest are you really earning? 19.56%. Any questions? Excellent. All right. Now that you got the concept of compounding, we're not going to sit here and do Excel spreadsheets compounding money. There's an easier way. Let's say that you wanted to invest $10,000 today, 6% interest, and you want to know what it'll accumulate to if it compounds annually for 40 years, you'll be sitting here all day. So how do we quickly calculate stuff? We use our finance calculators, or we can use these tables at the end of our book, or we could use a formula, whatever you're comfortable with. So let's see how this works. What's important with these time value of money problems is we understand, first of all, what we're searching for, then the appropriate interest rate and the appropriate time period. So Cindy Johnson invested $1,000 in a savings account for 3 years, paying 10% interest compounded annually. Pretty straightforward. So here's what's happening. Cindy is putting the money away today. We call that present value, times 0. She's only putting a single amount away, and it's going to compound and earn interest annually for 3 years. Now you could sit there and calculate the interest each year like we did, add it to the balance, calculate the next year, add it to the balance, calculate the next year. But if it was 40 years or 50 years, you'll be here all day. Then you don't even know if you calculated it right, unless you put your, like, look at me with Excel. I forgot 1 month. Okay, so how can we calculate that more quickly and efficiently? At the end of your book on page P1, it's a table. It's called the future value of $1. So this table was created by your author that has determined what the future value, so what something will be worth, what $1 will be worth in the future, given a certain interest rate and a certain number of compounding periods. And that's important. When you see periods over there, or the N on the left column, that's how many times this single sum, that 1,000 in this case, will compound until it reaches its future value. Since this compounds annually, once a year for 3 years, the number of periods is 3, the number of compounding. So what I do is, I want to find the future value of this $1,000. Well, this table says I could tell you what the future value of $1 is. Okay, give me an interest rate, 10% interest, compounds annually. So across the top, you have interest rates. Those are the rows, or columns, I'm sorry, the columns. So I'm going to go to the 10% column, and then I'm going to go down 3 rows because 3 periods. So the ends are the rows. And where that intersects, 1.331. And you see it on your screen there. What that's saying is the future value of $1 invested at time 0 will be worth $1.331. So if you want to know what $1,000 will be worth, multiply that, we call it the factor, times the $1,000, $1,331. So these tables are great if you can find your answer on the table. Here's another way. Formulas. So I'm just going to go ahead over to my Excel. Here's what the formula says. Actually, there's Excel formulas too, but we're not going to get into that. A formula to calculate future value, FV, is you take the amount, or what we call present value. Come on. PV, that's present value. So that would be the $1,000, and multiply it by 1 plus your interest rate. So the compounding interest rate, to the number of compounding periods, power. So that's a power sign. And that has the same sign on your calculator. It looks like the little carrot top on your calculator. I don't know if you could see that. So I could grab my calculator here, and I could say, for this example, the $1,000, I want to know what the future value will be $1,000 that has an interest rate of 10% and will compound. Oh, I'm sorry, guys. This is driving me crazy. Compound for 3 years. That's essentially what you're figuring out here. That's your formula. So if you know you're really into math and you know how to do all that on your calculator, it's really not hard. The first thing I do is take the 1 plus the interest rate. So you want to make that interest rate a decimal. So 1 plus 0.1. So 1.1. And then, like I said, I have a little carrot top here on my calculator in the right-hand column, halfway down, to the third power. And I get that factor, 1.331. Now multiply that by $1,000. So the formula, if you like to use formulas and you understand them, if there isn't a number on this table, you could use the formula. So what if your interest rate is 6.5%? Like, it's not on my table. No, but you can still use that in your calculator through a formula. Finally, for those of us who do have those scientific calculators that have the apps, and there are apps that you could download onto your phone for free, finance calculator apps. You want to click on the apps button, APPS, and it will come up with a few different selections, and you want to select finance. So finance is number 1, so I'm going to click 1. And then you're going to get more selections, and we want to do TVM, time value of money solver. And you get a whole bunch of variables on your screen. Hopefully you can see this. The first one is N. Now we already said N represents the number of compounding times. So mine is 3, so I'm going to put a 3 there. Use these arrows on the right-hand side to now go down to your next variable, which mine is I%. So that's interest percent. You don't have to put this in as a decimal on your calculator. You could leave it at a whole number. It interprets it as a decimal. So I have 10. Then I have PV. Well, that is the present value. And we know that it's 1,000. So I'm going to enter 1,000 using my arrows. I'm going to arrow down. If you have anything in a PMT, any numbers, just make it 0. Arrow down. Everything else could remain constant below that. Now I have my cursor blinking next to the FV, because that's what I want to solve for. You just don't hit enter here. To solve on a financial calculator for me, I have to hit a green button. It's called alpha on my calculator, and then enter. So alpha, enter, and you'll see in future value, it says minus 13331. So it's very easy to get your answer that way, as long as you put your variables incorrectly in your calculator. Now, when you get that negative number, don't freak out. Doesn't mean you have minus cash. Finance calculators and Excel is designed the same way. The assumption is if a number is positive going in, it means it's coming in. So at the end, it's going out. So it's just representing it as leaving or going away. So that's why it's a negative. Any questions on any of those? If you need help with your specific calculator, YouTube. YouTube shows you everything related to a calculator. Any questions? So 3 different ways. And we could even show you Excel really quick. If you've taken Excel, you probably used this in our formulas tab. We have a selection for financial right here. Click on that. And these are all the different formulas in Excel you can use to calculate financial items. Go down, we want to calculate for future value, FV. Opens up a dialog box, put your rate in, 10. That in as a decimal there. Okay. Enter. Playing games with me. All right. So 10, tab. NPER is your number of compounding periods, 3. PMT does not, that's nothing for us right now. We'll show you that later. So just leave it at 0. Present value is 1,000. I think you have to put the rate in as a decimal. Let me see. Yes. Put your rate in as a decimal in this formula. Hit enter. Oh, come on. It's had it solved for me. I got to put one more comma. There we go. At the end. Sorry. Oh. You guys having fun with this yet? Let's see. There we go. I see what I did. I put a formula in a formula. Try it now. There we go. Whew. Okay, so again, if you look up in your formula bar, there it is. FV, you put equals FV, parentheses, interest rate, compounding interest rate, you put in as a decimal, then you put the number of compounding periods, put a 0 for PMT, then your present value, end it with a comma, and then a parenthesis. So there's 4 different ways to calculate this. And you could see Excel also gives you that negative answer, not meaning negative cash. It's just the way whoever created these programs said that they should be created. Questions? All right, let's go back to PowerPoint. Share that. So let's do one more. Oliver Kim invests $5,000 in a bank account, earning 8% interest compounded annually. How much will he have in his account in 4 years? Now remember, the first thing you have to say is, what the heck are we solving for? Well, we want to know how much he will have in 4 years. So we are definitely determining future value. He's only investing $5,000 today. The number of compounding periods is 4 years, once a year, so 4. And the interest rate, 8% compounds once a year, so 8%. So you can go to your future value table on P1, 8% column, 4 years, go down 4 rows. you can see $1 will be worth 1.36049, and they tell us that right there. So how much will $5,000 will be worth? Multiply them. 5,937. Now, if you wanted to double check yourself on your calculator in your finance app, you go up and make your N equal to 4, your I equal to 8, PV, present value, 5,000, the amount he invests, arrow down using those arrows in the corner here, right corner, to future value, FV, make sure your cursor's flashing there, alpha, enter. What did I do wrong? I did something wrong. Future for 5,000. I'm getting a different answer. That's wrong. It should be 6802. Good thing I double checked it. So the PowerPoint is incorrect. Your answer should be 6,802.45. So instead of finding out how much interest he earned first year, adding it, recalculating interest for the second year, adding that, recalculating interest for the third year, quick and easy. Oh, and there's the answer, but they tell us the wrong answer in the slide. All right, so that's future value. Sometimes we know what we need in the future. So we got to figure out how much do we have to put away today to get to the future. So in this case, we're trying to determine or figure out the present value. You will always have 3 of the variables because you need 3 of the variables to calculate the fourth. Now our formula changes just a little bit. Remember, future value equals present value times 1 plus interest rate to the number of compounding periods power. So if we do some algebra, we could say, well, then present value, the amount we need to put away today, or we need today, equals the future value divided by 1 plus the interest rate, the compounding interest rate, to the number of compounding period power. So take a look. We know the future value. We need to accumulate $1,331 in a savings account by the end of 3 years when interest is earned at 10%. Future value, we know we need $1,331 divided by 1 plus the compound interest rate, which is 10%, 1.10, to the number of compounding period power. So and you should always solve for those parentheses first, right? I'm not huge, I don't remember all the math rules, but that's definitely what we want to do first. So take 1 plus 0.1 to the third power. When you put that in your calculator, you'll get that 1.331. Divide that into 1331. So if you're using the formulas, that's what you do. Present value is 1,000. If you say, well, we already know that. Yeah, but what if we didn't? What if we knew what we needed, the interest rate, and how many periods we could leave that money in there? Also, if you flip your page in the end of your book, there's a table we can use. And this table is called the present value of $1. So what it's saying is here's what $1 in the future is worth today, given this interest rate and this number of periods. So if you want to know what $1 at the end of 3 years, which has been invested and earning 10%, is worth at time 0, the day it's invested, it's worth 75.31 cents. So what it's saying is if you invest 75.131 at time 0, at the end of 3 years, interest rate of 10%, you'll have $1. So if you want to determine what's the value of the present value of $1,331 that was received at the end of 3 years and was invested for 10%, go to this table on P2. It's set up just like the future value of 1. Go to your interest rate. So that's your compounding interest. Number of compounding periods, 3. 0.75131, since that's what $1 present value is given those investment factors. Multiply that by what $1,331 future value. So the present value, 1,000. You still get the same answer. Now, if you're using your scientific calculator here, go into your apps. If you're not there already, finance, TVM solver. Your N, 3, I, whole number 10. Make PV 0, because we got to solve for that. PMT is still at 0. We'll talk about PMT next Monday. Future value, FV, put that in as 1331. Now using your arrow keys, these big bulky arrow keys, move your cursor back up to PV. So it's flashing next to the equal sign. Alpha, enter for solving, 1,000. And again, if you put your future value in as positive, the present value is going to come out as negative. You can see that or not. Hopefully you can. In my screen there a little bit. Questions? Let's take a look. Given a choice between 1,000 now and 1,000 3 years from now, would you choose to have the money now so you could earn interest on it? Probably. So you want to have more control over that. But given 740 now and 1,000 3 years from now would depend on your time value of money. What does this mean? At a rate of 10%, so if the current interest rate is 10%, you need to determine what is here's what you do. You're either going to determine what is the future value of $740 at the end of 3 years, given a 10% interest rate, or what's the present value of $1,000 given 3 years, 10% interest rate. So you could do it either way. Now in this one, they want future value. So we go to our future value table and they said, we are going to see how much $740 will be worth at the end of 3 years, given a 10% interest rate. So if we use the future value of 1 table, 10% column, go down 3 rows because there's 3 years or compounding periods, And there's your factor of 1.331. Multiply that by the present value, 740. So that $740 in 3 years, given that 10% interest, will be worth $985. Take the $1,000 in 3 years, it'll be worth more. You'll get an extra 15 bucks. But what if the rate was 11%? Go to the next column over. 11%, 3 periods. Now your factor is 1.36763. So what that's saying is, again, that's what $1 would be worth in 3 years at 11% interest. We want to know how much $740 will be worth. So multiply it by that 1,012. So if the going interest rate is 11%, you should choose the $740 now, because it'll accumulate to 1,012 in 3 years. So don't take that $1,000 in 3 years, take the 740 now. So you can see how we're starting to use these calculations to make choices. Any questions on that? Take a look. We have, and when I was being taught this, we always used timelines. So when you're reading through word problems, you really want to try to first determine what the heck they give you. That's half the battle with this chapter. Did they give me present value, future value? Do I have an interest rate? Do I know my number of compounding periods? Do I know my compounding interest rate? So what we just went through is depicted on this timeline. Present value is always at time 0. That does not mean January 1. That used to freak me out too. What, is January 1? No, it's just today. And 1 year is 1 year from today. It's not January 1 necessarily. Future value is the end of 3 years from today in this scenario. So future value adds compounding interest. When we're calculating present value, we take out all the interest. Okay, so it's just future value, we're adding the interest. When we're calculating for future value, when we're calculating for present value, the interest is already in this future value over here. So we're removing it to get back to the original investment. So another one, Versatile Company purchased a delivery truck on February 1. The agreement required Versatile to pay the purchase price of $44,000. Here we go. February 1, 2022. 1 year from now. Assuming an 8% interest rate for loans normally, what was the price of the truck? Right? So I kind of showed you this scenario in the very beginning. Remember, bought a piece of equipment. We're going to pay $10,000 at the end of year 1 for it, and then $10,000 at the end of year 2. Well, what's the original cost of the equipment? That's a present value calculation. So at the end of the first year, we're paying $44,000, but included in that $44,000 is 8% interest. So we need to calculate present value of 1. And how would we do that? Well, we can go to our present value table. 1 year, 8% interest. So go 8% column. At the end of period 1 is 1 year making that $44,000 payment. So you can take the $44,000 future value times 0.92593. That truck cost $40,741. What's so important about that? you need to know how much to debit the vehicle account for when you buy that. You don't debit it for $44,000. No, because that future payment has interest in it at 8%. So we've got to pull the part out of that payment that will be interest and only record the, if you want to look at it, the principal or what the actual cost of the truck was, $40,741. Before we finish up for today, what happens if this happens? Suppose a friend asks to borrow $500 today, present value, and promises to repay you $605 in 2 years from now. So you know present value, you know future value, and you know how many compounding periods. But you don't know what the interest rate is. And you need to know that. What is the annual interest rate you are agreeing to? Well, you don't go a 105 divided by 500. No, because that's 2 years worth of interest. What you do is set yourself up. Here's my present value. Here's my future value. So now you got a picture of this. 2 years. I need to find I. Now you could take either one of these approaches. You could use a formula. So either use the present value formula or the future value formula and solve for I. You have to, if you're really good in algebra, you can do that. You can use the tables though, and I'll show you how to do that. One way to calculate the I, you can use your present value formula, where present value equals future value times that factor from your table, what $1 is worth in the future or the present. So we're trying to figure out here the present value of 1. So algebra, 500 divided by 605. Your factor, not your interest rate, your factor is 0.82645. So what we do is we go to our table and we say, okay, we know how many periods, how many compounding periods there are. So we go to that row on the present value of one table, and we go across that row until we come close to that factor of 0.82645. And it lands right on it, 10% interest. So the column that factor is on, that's your interest rate. Or you can use your apps on your calculator, which is a wonderful thing to have. So your N is 2. Your interest you're going to solve for, so make that a 0. Now, when you're using your calculator and you know present value and future value, you must put one of them in as a negative. But here's the key. Your negative, and hopefully you could see this, is the little negative sign on your number pad in parentheses. That's what you use. You don't use the minus sign that you would use if you were adding or subtracting. So I'm going to put minus as my present value, minus 500, and then I'm going to use my arrow keys and make my future value positive 605, or you can do vice versa, doesn't matter. And then I'll use my arrow keys to move my cursor back up to the I%, and then alpha, enter, and I get 10. Okay, so, or you can use your present value formula, where you would put 605 divided by 1 plus I to the second power, but then you'd need to know how to solve for that. Any questions? Really quick, I got 2 minutes left, 3 minutes. What if you want to invest $10,000 today and you needed to accumulate to $16,000 in the future for grad school? You can make it, put the money away in an investment that will earn 10% compounded annually. How many years will it take? So you have 3 of the factors: present value, future value, and the interest rate. You're trying to figure out how many compounding periods will it take to accumulate to that. You could take the same approach. Take your present value divided by your future value. Go to your present value table. So here, if we do that, 10,000 present value divided by future value of 16,000 gives us 0.625. We can go to the 10% interest rate column and start going down that until we reach somewhere around 0.625. And it looks like 0.62092 is the closest we come. We can say it'll take about 5 periods. Now that's not exact. So if you want exact, you can go into your calculator. You're solving for n, so you want to make sure n is at 0, I is at 10, and your future value is and present value are entered. Make sure one of them is entered with that negative, and then alpha, enter. Oh no, I'm sorry, it's a different number. Sorry, present value should be either positive or negative 10,000, using that little minus sign with the parentheses around it to put negative amounts in. And then 16,000 is my future value. I'm going to use my arrow keys to go back up to my n and solve. It's really 4.93 periods, or in this case, years, because it compounds annually once a year. So the exact answer, 4.93, 5 years. Phew. So compound interest. So today we looked at how we can determine how much a single amount, one investment, one amount can accumulate to given number of compounding periods and an interest rate. We also went backwards. If we need to know how much do we need to put away to accumulate a certain amount of money given a certain period of time, compounding periods, and a compound interest rate. We also saw how to determine an interest rate under this scenario and periods. So some of the accounting applications monetary liabilities, we may need to do some present value calculation with these items. Okay, and then we'll start with this on. You guys can take a look at this example just to show you how we use, this is kind of similar to the example that I was showing you in the beginning of class. You take a look at those, let me see. About it, yeah, that's where I wanted to end. Okay, so Monday, because we don't have class Wednesday because of teacher in service, Monday when we come back, now we're going to get in and kick it up a notch with what we call annuities. Now we're going to change this scenario. Instead of making one investment or one payment and see what it accumulates to, now we're going to be making payments over a period of time of the same amount, and the pay, and we're going to determine that. How much will those payments accumulate to, or how much are those payments that are made worth? And really, this is how we figure out how much the lottery is. So when it says, oh, there's a $20 million lottery. Now, that's a $20 million lottery if you take annual payments of so much money for 20 years. But what if you take the lump sum? That's one of these calculations. So just a little preview for next Monday. And we'll probably be wrapping up the lecture next Monday. So I'll make this available out in Blackboard for you guys. Any questions? Okay, well, thank you very much for joining me this way. I really appreciate it. I hope everybody's safe and no issues. And then just stay tuned for how we're going to proceed with next Monday's class. Okay, and for those of you, we're either going to be totally on Zoom, or some of us will be in the classroom and some of us will be in Zoom. Okie doke. Thanks. I feel like I'm at home. Take care, everybody. I'll see you next week.